Yeah, thanks very much for everyone. Thank you, Bo, for your nice talk, and Iping. So it's nice to share the stage with you. Also, thank you to Jason and all the PacBio colleagues who have put on this nice meeting. So thanks for your time. I'll go also pretty quickly due to the time constraints and the chill in the room. I don't know if anyone else is cold, but I am. So anyway, thank you very much. This is basically a pitch to educate you on secondary analysis offerings. This is a software that works with PacBio short or long read data. So we're a software company. I'm the businessman for it. I'll literally email you the software and you can use it for free. You can buy it. Either way is fine. We're here to support you and your work. Again, you can think of it as an accelerated software. So it's like very elegant, efficient algorithms, and I'll have data later on how like our software can be used to be faster than and more scalable than like a GPU or FPGA alternative. We do simple licenses. It's me doing it, so it's pretty simple. We're probably the world's most awarded bioinformatics team because we've won many awards. We're also a 2-time Bio IT award winner in Boston. It's just a conference that makes money by promoting different Bio IT solutions to Bio IT professionals, which is what I am, I guess. This is our usage map for when the software, we can record it. So if your country, where you're from, is not represented here, we would obviously love to work with you and share the software with you so you can use it. And again, this is basically a secondary analysis solution, so probably everyone knows what that is. But first, right, the primary analysis is literally reading out the DNA, like from this big Revio, and then we are just a software binary that runs wherever you want. Meaning, in your snakemate, your bioinformatician sets it up and does whatever they want with it, basically. And it's all modular, like little pieces. Like if you're just using Minimap 2, we have a Minimap 2 that's 5 times faster. So it just will produce the same results for 5 times less cost and compute time. And then it's whatever your downstream application is. We're a very focused company. We're only 11 people. And so we're very focused on just FASTQ, BAM, CRAM, VCF, GVCF manipulation and stuff like that. And so again, when we started 9, 10 years ago, it was kind of like, let's not make yet another variant caller. Let's do the same, faster, cheaper, meaning like the engineers at Sentieon, not me, I'm a biologist, but the engineers are, good at physics and whatever else that makes extremely efficient algorithms. So we could take like the identical math, right, and just express it more efficiently in computers, right, with lower memory, with also nicer software. Like our software is completely self-contained, so you don't have to manage anything. It also automatically parallelizes. So if like a lot of different computer applications are single-threaded, none of our software is single-threaded. It can be on as many threads as you want. It could also be distributed to as many servers as you want. And then we also provide support with it. It's also excellent for the clinical as you go deeper, as you're sequencing deeper. We don't downsample. A lot of different software tools will only look at so many reads in a region. So we really just don't have any scale problems. And I like bioinformatics because it's it's extremely quantifiable. So it's just, you can test it. You can test it for as much as you want. And it's like, are the results accurate and consistent? And ours are. We can efficiently meet whatever turnaround time goal. I'll talk about it later, but we just had we work on all CPU and ARM, and so Intel, AMD, and ARM, and all three of these, mega companies just benchmarked our software and published marketing material because they like it so much and they want to compete with NVIDIA and Illumina. Although my favorite benchmark is with AMD, and AMD also makes the Illumina Xilinx FPGAs, right? So either way, I'll show you that in a minute. It's very nice. But basically, and like Bo was saying, we want low cost, right? We're here to save you money and like headache and time and your bioinformatician's time. And I like to say, And Chris Dwan likes to say, like, it's nice when bioinformatics is boring because then it's automated and running, right? Like if you're running 10,000 samples, you don't want to be like, you know, why is my pipeline crashing, right? So ours doesn't do that. And people do, we have tons of clinical diagnostic customers who, you know, set up these pipelines and then they run effectively. So it's, you know, it's kind of, you can save your company's money or your academic institute's money, but also you save your time not messing with subpar software. So here's one of the one of the benchmarks. So this is the AMD benchmark. It's going to show PacBio, and then I'll also just use this like as a stand-in for the ONSO, right, for long and short read. So what AMD found, and something I thought was interesting, is the PacBio HiFi. Right now it costs us $2 in American cloud in Amazon to process a full PacBio pipeline. And when I talk to other people, it's more like $15. So that means, you know, we're in eight times per sample cheaper than like an open source alternative, right? And so then if you're spinning up, if you want to do 10,000 samples or whatever, it becomes great. And another just thing from this finding is the Oxford nanopore, if it's you know, the same 30x genome, with our software, it's the same software, it's the same quality of algorithms that are processing the data, but the ONT data takes 2.5 times as long, right? And that's basically because of the additional noise in the data. Like if you're thinking, like HiFi is a good branding decision, right? For one, you know, people who like music and like high fidelity things, but also people like high fidelity like you want high fidelity sound waves, you know, bathing you in a nice sound of whatever music you like, and you also want high quality data, so you don't have to be confused about, you know, what are the results. But anyway, and we can also do, there is no like time issue. Like we can, for $2, we can process a PacBio genome in 17 minutes on a single server. So if you want to split it onto 10 servers if you want, it'll maybe cost $4 because of the additional overhead, and it'll finish in 2 minutes. But nobody needs that. But it can be as fast as you want. Here's the example like I was talking about. You can see the bottom, this is PacBio, right? So 16 minutes on a single server for 30x alignment and variant calling, compared to, here's the ONT. And this is still excellent for ONT as well. Our software, it works great for both. But you can just see that double the runtime, right, for the same data. So I thought that's interesting from a long read thing. And I'm not publishing this, AMD is publishing this. And then here's the cost again too, right? So $2 and 17 minutes. It's basically solving, right, the secondary now, like our customers are just like, great, set it up, and then it's a production-worthy software. And then we produce, it also works with all the other things like PacBio. Like we are not here trying to make all software in bioinformatics, right? Whenever there's a good software, like Mike Eberle's group from PacBio produces a lot of great software. So we're really like a backbone for the compute-intensive, more expensive compute parts for the alignment, processing, whatever, small variant calling, and then you can bring in whatever like TRGT or paraphase or whatever is important for your assays. What is this one? Oh, this is for short read data. So this is us being, this is confusing because AMD needed to use something that was published. So this is comparing us, so it costs $1.50 to process a 30x short read genome, compared to, this is NVIDIA on Oracle, but Oracle Cloud, because they're playing catch up, right, with Amazon, is way cheaper. So the Amazon one is unpublished, but it's like $24. So we're about, whatever, 15 to 20 times cheaper than Parabricks for the same data. And then that's how we can sell the license, right? We're like, great, if we saved you $1 million in compute for your stuff, you know, you can give us a couple $100,000 or whatever. Or if we're saving you $100 in compute, you can just use the software for free for your stuff, because I'm not trying to bill you for that. It just depends on how much usage you have. This is a user. This is just like an easier way to do it. This is more for the bioinformaticians. It's an easier way to run our software because this is all just modular, high-performance computing tools. Like there is no GUI. There are no users, right? Our software is a Unix-style binary of 50 different tools for genomic data analysis. So in the interest of time, I'm going to skip over this stuff because of our earlier technical difficulties. I'm happy to email these slides to anybody. Obviously, you can see here, though, here's the PacBio accuracy. It's great, as everyone knows. That's why we're here. And you can also see the high structural variant accuracy. So we also have a structural variant tool, but you can use as much stuff as you want. These are just some general supported features for PacBio, right? We can do diploid or haploid. We can also do GVCFs, which is nice. So as you're doing more population analysis, we have a very nice joint calling, and we do RNA, whatever. This is kind of the pipeline at a high level. So this also does the phasing. And what we're replacing is basically the regular open source Minimap 2 and deep variant for PacBio data. And then instead you just use our tools and get all those benefits. And here is some accuracy data. So you can see less is better. Here's 3 samples. So this is where we're more accurate, but it's also good. Either way, the accuracy is fine. I'm more competing on the latent issues, the compute costs, the ease of use, that kind of stuff. Here's another, these are really zoomed in, right? 0.95. So I say these are equivalently accurate, but ours is usually a little better. The other thing that's nice to see, this is based on coverage. So these are different coverages, but you can see different structural variant tools. So here's Sentieon in the blue, Sniffles 2, which is a great tool, QtSV and PBSV, which are also good, but you can see this is also very zoomed in. These are all, structural variants with PacBio is great. Structural variants with short reads is a waste of time unless you have a specific panel that you've already designed it for. If you know what you're looking for, then it's fine, I guess, but good luck to you in the short read world of structural variants. I would go for these more accurate ones. And again, we support a lot of big population projects, and we have the most scalable joint calling solution definitely in the world. It still doesn't go that high. We can do about 500,000 samples with the GATK math, but that'll get pretty expensive. But it'll still be 10 times faster and more efficient than the regular GATK one. And again, software is available to run anywhere in the world, so you can run it on your local computer, you can run it on your MacBook if you want, but that you don't want to, or you shouldn't. If you want to put your own genomic data on your MacBook, you can. But it's just going to show that it's flexible, it can be deployed anywhere. So any cloud, we literally just email it to you. I'll sell it to you, so I'm pretty pleasant is usually what people say. And then one other thing that's really interesting is we're going to have out, maybe in about a month, a kind of hybrid approach where we can use PacBio HiFi reads in coordination with short reads. So if you have the same sample that is both, we'll use the HiFi read and the short reads together, in context with each other. And what I'm told is the accuracy is fantastic coming out of that. That'll be even better. So we'd have more information on that in the future. But if you're interested in that, or if you're doing, like you said, the pull downs where you're doing a hotspot, this could be for PacBio whole genome with a short read whole genome combined, or just the panel approach. And you don't need that much coverage, which then helps PacBio scale more. So I think we're thinking it's going to be 10x or 12x of the HiFi reads with somewhere between 20 and 30x of the short reads. And then that will be an extremely accurate representation and better than either technology alone, right? Because they both have some issues. But in general, all genomics has really advanced a lot. It's a wonderful place to be. And so we offer free trials that are basically open-ended, and we sell the license. Everything's good on our end. Here's some benchmarks. I liked what you guys had, the four benchmarks up. So this is, AMD saying that we're 15 times faster and cheaper. Here's Intel with Charité. We did a single cell application that also has like a 15x acceleration compared to the pipeline we were replacing. Here is ARM doing it with one of our customers, Gencove, which is an interesting agricultural company. Again, we work with reference, like any reference. If you're doing alignment and variant calling, our software will help you. And Gencove is a pretty cool agricultural company that does a lot of low-pass sequencing. And then here's one from Mayo Clinic, which is, so Charité, I was told, is the Mayo Clinic or the Harvard of Europe or something. I don't know anything about that, but it's in Berlin and it's a fancy hospital. Also, Mayo Clinic is a fancy hospital for people who like fancy status things. So it's nice when these institutions are using your tools and are like, oh, they're great, because then other people are like, oh, seems like it's good. And again, we have tons of documentation, tons of different things for the bioinformatics people to use and leverage. And this is not stale, right? We're consistently developing on it. Like I said, we're going to release this interesting hybrid approach, which I think is quite future looking, because I'm talking to occasional people who have this data that could take advantage of that, but it's more future looking. We're also going to have a new CNV tool, things like that. So I just want to say thank you again. It's been a lovely conference.